Hello. Sorry about my voice. It is not good. Solving multi-step equations with variables on both sides. Our learning goals are: I will be able to solve multi-step equations with variables on both sides. I will be able to verify my solution. So we have talked about multi-step equations, and our process is: first, remove parentheses using the distributive property. Second, combine like terms. Third is isolate the variable term, and then remove the coefficient using inverse operations, and finally verifying our solution. But what happens if there's variables on both sides of the equal sign? Well, the solution is simple. We need to get all of the variable terms on one side, and this completes our process. Our first step, as always, is remove parentheses using the distributive property. And then we're going to simplify expressions on both sides of the equal sign by combining like terms. Remember, you can only combine what's on one side. Move all the variable terms to one side of the equation. Move all non-variable terms to the other side. Isolate the variable using inverse operations, and verify our solution. So I've changed the wording up a little bit on our process steps, but I think it'll be fine. Remember, not every equation needs every step. If there's no parentheses, you don't need to distribute. If there's nothing to combine, you don't combine like terms. So here we go. Let's try an example. We have -4 times the quantity r plus 6 equals -12 minus 6r. So you can clearly see in red, we have r's on both sides. But our first step is to remove parentheses using the distributive property. So we're going to distribute that -4 to both the r and the 6. So when we do that, we end up with -4 minus 24 equals -12 minus 6r. Now, we can't simplify either side any further, so we're not going to use that step. We look and see we have variable terms on both sides. So we want to move all of the variable terms to one side, and we want to move the smallest one. So -6 is smaller than -4. So what we're going to do is we are going to remove this -6r. And the way we're going to do that is we're going to add 6r to both sides of the equation. And when I do that, I get 2r minus 24 is equal to -12. Okay, what's our next step? Well, we want to get all the non-variable terms on the other side of the equal sign. So we want to get that -24 and turn it into a 0. How do we do that? Well, we add 24 to both sides. And when we do, we get 2r is equal to 12. So now we have all of our variable terms on one side and all of our not variable terms on the other side. So we want to isolate the variable using inverse operations. 2 is multiplying that r, so the way we remove that is by dividing. So we divide both sides by 2, and we get r is equal to 6. And that is our possible solution. So we are going to put that back into the original equation and simplify both sides and see if we get a true statement. So when we simplify, we do get -48 equals -48, which is a true statement. So our solution is r equals 6. Let's look at another one here. We have negative 8m minus 12 equals 2 times 8m plus 6. Our first step is to remove parentheses using the distributive property. So we're going to leave the first side, the left side alone, and we're going to distribute the 2. So we get negative 8m equals 12. I'm sorry, negative 8m minus 12 equals 16m plus 12. We want to move all the variable terms to one side. Negative 8m is smaller than 16m, so that's the one we're going to move. To turn negative 8m into a 0, we're going to add 8m to both sides. And we end up with negative 12 equals 24m plus 12. Now, some people don't like it when the variable is on the right side, and that's okay, because what you can do is you can flip the sides. Negative 12 equals 24m plus 12 is exactly the same as 24m plus 12 equals negative 12. You can take what's on the right side of the equal sign and what's on the left side of the equal sign, and you can flip them. So now I have all my variable terms on one side. I want to get all my not variable terms to the other. So I want to get rid of this plus 12 that's hanging out with my 24m on the right side. How do I turn plus 12 into a 0? I subtract 12. And I get negative 24 is equal to 24m. My next step is to isolate the variable with inverse operations. M is being multiplied by 24, so I'm going to divide both sides by 24. And I get a possible solution of m equals negative 1. So I plug it back into my original equation. I do some simplification, and I end up with negative 4 equals negative 4, which is true. So I know my solution is m is equal to negative 1. Let's look at some practice problems. First, I have 33 minus 7x is equal to negative 3 times 7 minus 3x plus 2x. First, I'm going to remove the parentheses by distributing the negative 3, and I get 33 minus 7x equals negative 21 plus 9x plus 2x. Next, I want to simplify each side of the equal sign by combining like terms. I can combine my 9x and my 2x, so that's what I'm going to do. And I get 33 minus 7x equals negative 21 plus 11x. So now my sides are simplified. Next, I want to get all my variable terms on the same side. So negative 7 is smaller than 11, so I want to move that one. So to turn negative 7x into 0, I'm going to add positive 7x to both sides. And I get 33 is equal to negative 21 plus 18x. So now I have all my variable terms on one side. I want to get all my not variable terms on the other. So I want that negative 21 to become a 0. So what I'm going to do is add 21 to both sides. And I get 54 equals 18x. So now I have all my variable terms on one side, all my not variable terms on the other side. I'm going to use inverse operations to make that x be alone. So I'm going to divide both sides by 18. And I get x equals 3. That's my possible solution. I'm going to plug it back into my original equation, and I'm going to simplify both sides, and I get 12 equals 12, which is a true statement. So I know my solution is good. So because my voice is so awful, I am just going to show the steps of the rest of the practice problems, and when my voice is better, I will come back and re-record the slide.